Chemistry practice.
Today, we're going to be looking at stoichiometry practice problems, how to go from grams of one substance to grams of another, and how to find our starting point and answer what we're being asked. So whenever you're given any type of stoichiometry problem, any type of conversion problem, I just want you to separate what you're being asked and what you're being given. First step is to read the problem. It says, use the following equation. So that means that I'm going to be looking at specifically this reaction right here. Calculate how many grams of iodine are needed to prepare 28.6 grams of ICl by this reaction. So right off the bat, it's telling us what they want. They want how many grams of iodine. So now we can write down what we're being asked. And what we're being asked, grams of I. Now what are we given? 28.6 grams of ICl. So we're given one thing, which is our starting point, and we must go to grams of iodine. Something that I want you to note is that the universal language for chemistry is the mole. In chemistry, the only way to go from grams of one thing to grams of another is through the mole. And you'll see what I mean by that right now. So we've established that our starting point is 28.6 grams of ICl. Now, when you're doing conversion or stoichiometry problems, I want you to memorize this formula. You're going to put your given unit at the top, given unit at the bottom, so it has to match up with this unit over here so you can cancel it out and put whatever you're desiring, so what you want to end up with in the numerator. So we have 28.6 grams of ICl. So what do we have to put here so that it can cancel out the grams of ICl? Well, we can use its formula mass. So in ICl, we have iodine and we have chlorine. And if we look at the periodic table, iodine has an average atomic mass of 126.90, and then chlorine has an average atomic mass of 35.45. So what you're going to do is add these two together, and that's going to give you its formula mass. So I got that iodine and chlorine's formula mass together is 126.35 grams per mole.
So I actually have no clue why I said 126 when I meant 162. I do make that mistake a little bit more in this video, but don't mind that, please.
Why is this in grams per mole? Because the periodic table measures elements in grams per mole. And I know that the only thing that can cancel out grams of ICl is its formula mass, because it would be 126.35 grams of ICl per 1 mole. Now, how do you write that down? Well, I would put 1 mole of ICl in the numerator and 162.35 grams of ICl in the bottom, because that's how it's read, 162.35 grams per mole, and that as a fraction is exactly this. So now we're in moles of ICl, and that's exactly what we want, because as we mentioned before, the only way to go from one substance to another is through the mole. How can we go from moles of ICl to grams of iodine? If we were able to go from grams of ICl to moles of ICl, then that means we can go from moles of iodine to grams of iodine. And how we can do that, how we can connect moles of ICl and grams of iodine, is through our molar ratio. Basically meaning all the coefficients that all the compounds in this reaction have tell us our ratio, our recipe. So what does this reaction specifically tell us? Well, if we have 2 moles of this, 1 mole of this, and 6 moles of this, we can make 5 moles of this, 1 mole of this, and 3 moles of this. So we have 1 mole of ICl. And in this problem, I can only find ICl on my product side. And it says that I have 5 moles of ICl. So 5 moles of ICl. Notice how I wrote it in the denominator. Why did I write it in the denominator? Because I want to cancel out my moles of ICl. I don't need moles of ICl, I need grams of iodine. So what do I want in my numerator? What matches 5 moles of ICl? So now what do we do? Well, I'm in my moles, and we said that if we go to moles, we can go from substance of one thing to substance of another. So this is perfect. And our molar ratio tells us that 5 moles of ICl give us 2 moles of iodine in this specific reaction. So that's exactly what we write. 5 moles of ICl, 2 moles of iodine. Now what I want you to notice is that in this problem, we technically have 4 iodines because we have this coefficient of 2 times that 2 with the subscript. So you're going to see what we're going to have to do. You know how we did grams to moles? we're going to do the opposite. We're going to do moles to grams. And in the exact same way that we did it this way, you have to use the formula mass. Anytime you want to go from grams to mole, you have to use its formula mass. Why? For this reason right here. So now we have 2 moles of I2. Now, I don't want to lose you in this next step. We have 2 moles of I2 up here, but we're not being asked moles of I2 or grams of I2. We're being asked grams of specifically iodine. So what we can do is isolate that iodine. So yes, we know that with 5 moles of ICl, we also have 2 moles of I2 due to the molar ratio, right? The coefficients. But we also know that in 1 mole of I2, there's 2 moles of iodine. Why? You have I plus I equals I2. And I did this just for the sake of isolating my I. Now, I'm going to clean this up a little bit. So let's cross out what we have on the top. So we crossed out grams of ICl. We crossed out moles of ICl. Crossed out moles of I2. All right. Now, we're left with moles of I, but we want grams of I. So that tells us that we have to write moles of iodine in the denominator because we want to cancel that out. And our desired is grams of I at the top. And again, like I mentioned earlier, the only way to do moles to grams, whatever, is through the formula mass. In iodine, you have 126.90 grams per mole. So now we can cross out our moles of I because it crosses each other out diagonally. And what I like to do is multiply across the top first and then the bottom. And then once you have a fraction, you can just directly divide. It's just easier on you and less room for mistakes. So for my numerator, I got a really big number. I'm just going to write it down. It's going to be 811.75. And now I can divide these two directly. And my answer when I divide these two things is 17.88. But we want to do sig figs, so that's going to be 17.9 grams of iodine. How did I get grams of iodine? Well, let's look at all of our units of measurement. And this is also why it's so important to never forget your units of measurement. We cross out our grams because we had it here. Moles of ICl, moles of ICl, moles of I2, moles of I2, moles of I, moles of I. And we're left with our desired, which is grams of I. Boom, 17.9 grams. This would be our final answer right here.